Microservices, a very popular architectural style that is used by many big companies, including Netflix, Google, Spotify, Amazon, Uber, and pretty much every company these days are using microservices to deploy their application. So in this DevOps project, we are going to learn how you can create Python Microservices application, which is going to convert video into audio and deploy it on AWS Cloud using tools like Kubernetes, Helm, Docker, RabbitMQ, and also databases including Postgres and MongoDB. So let's go ahead and deploy this. But before we deploy, to make things easy, let me explain you the architecture diagram. So this is our application. In our application, we have 4 different microservices: the auth service, converter service, gateway service, and notification service. Along with this, we also have the Helm charts to deploy RabbitMQ, MongoDB, and Postgres. So the application works in a way where the user is going to send a request on API gateway. API gateway have 3 endpoints: login, upload, and download. First, the user is going to log in, and if the user is correct, checking the credentials in the Postgres, it is going to then generate a JWT token, which will allow user to upload a video. When a user uploads a video on this path, it's going to be stored in the RabbitMQ, which is then transferred to the converter service that converts the video into audio and then store the data in MongoDB, which is again deployed through Helm chart. Once the video is converted into audio, we are going to get notification on our email ID using the notification service, and we can also go ahead and download it through the download path, and we can then have our converted audio using this application. So this is our Python microservices to convert video into audio. Let's deploy this. Alright, I hope now you have an idea of what this project is and you are excited to do this project. But before we start, there are a few points that you need to know. This project is not a free project. You will get charged for EKS clusters as it's not a free tier service. But I still encourage you to do it because you will learn how microservices are deployed and how they work. So do this project. So I hope you complete this project. Most of you will face issues in this project. If you face issues, try to go through the GitHub README section properly, troubleshoot it. But if you still face issues, let me know in the comment section. I will help you out. I hope you complete this video, share it on your resume, even on your LinkedIn profile. So all the best. Let's start with this project. Alright, so I'm here on my computer screen, and let's start with deploying our Python microservices application on AWS Cloud using tools like Kubernetes, Helm, Docker, RabbitMQ, and also databases including MongoDB and Postgres. So let's start with deploying this application, but before we actually start, there are some prerequisites or tools that you need to have to be installed in your machine in order to do this project. So the first thing you need is an AWS account. As we are deploying this application on AWS Cloud, and we are using Elastic Kubernetes service, you need to have an account. And if you don't have it, you can follow the steps here in this documentation. Similarly, you require Helm. We are using Helm, the Kubernetes package manager, to install MongoDB, RabbitMQ, and Postgres. So you require Helm to be installed. I already have Helm installed in my machine. Let me show you. If I run Helm version command, you can see Helm is installed. Along with Helm, we also require Docker because we have Docker files and we are going to be creating Docker images and pushing them on Docker app. So you need to have Docker installed. And if you don't know how to install Docker, you can go to the official documentation or watch my previous Netflix video, which has the commands to install Docker in your machine. Along with this, you also require Python. As this project is in Python, you need to have Python installed. Mostly every laptop or machine comes with Python installed. If you don't have it, just search for Python 3 and it should be inside the shell if you have Python installed. Along with this, you also require AWS CLI. We are running some AWS commands, so we need to have AWS CLI installed as well. I have it installed, and if I run AWS version command, you can see AWS CLI is installed. Along with CLI, you also need kubectl. We are running some kubectl apply commands. So kubectl is a tool to manage Kubernetes through command line, and I already have it installed. Again, if you don't have it installed, you can watch my previous cloud native voting application project, which has the commands to install Kubernetes or kubectl. So if I show you kubectl version command, you can see it's there. Alright, let's along with this, lastly, you also need to have PostgreSQL and MongoDB installed in your machine because we are going to test some connections and also run some queries inside the database. So you need to have Postgres and MongoDB installed. Once you have this installed, you are then ready to start with the project. To start this project, I'm going to clone this repo in my local machine. So I'm going to copy this link, open my terminal, and I'm going to say git clone, paste this. So I already have it cloned. So it says already exists and is not an empty directory. So if you clone it, you will see the code. Let's go inside this particular folder. And if I show you, there are different folders: assets, Helm charts, project documentation, and source folder. Before I explain you what is there inside these particular folders, let's go and create our Kubernetes cluster, because creating a cluster takes time. So I'm going to go to AWS dashboard, click on Elastic Kubernetes Service. We are going to be creating a Kubernetes cluster on AWS, and we are deploying this microservices application on our cluster. So I'm going to click on Add Cluster option, click on Create. Let's give a name. So I'm going to name this as Microservices, and then for the version, I'm choosing the default one, no need to change it. For cluster role, I'm choosing my Amazon EKS cluster role. And if you don't have this role, you're not sure what are the policies inside this, go through the README section. In this README, I have some screenshots which explains you what policies you need to have in this particular role. Similarly, also for the node role that we are going to be attaching to our node group. So after you attach the service role, click on Next. For networking, I'm choosing the default VPC, and I'm only allowing my public subnets. So I'm removing all my private ones. For you, it might be only public because I created them extra. So these are all my public subnets. For security group, I'm choosing my SG. You can choose your any security group. For cluster endpoint, I'm choosing it public, and then no need for logging. No need to attach any extra add-ons apart from what you have here. So I'm going to click on Next. No need to change the version for the add-ons. I'm choosing Next now. You can review everything and then click on Create option. So this will now start creating the cluster, and creating a cluster usually takes around 5 to 10 minutes. So till the time the cluster comes up in active state, let me explain you the code. So I'll open this folder on my VS Code. So let's open VS Code. Okay, so as you can see, there are 4 folders: assets, Helm charts, project documentation, and source. Assets has the video, which we are going to be converting from video to the audio after we deploy this application. And to convert this video into audio, we have some microservices here. As you can see, this is the auth service, and you can find the code for the auth service here. It is used for authentication, and the credentials are stored in the Postgres database. This is why we have scicopg2 library, which is a Postgres library that can be used with Python. So this is required for authentication, and if it is authenticated, then the user can put their video, which is going to be converted, and we will also get the notification. So for you to upload the video, we have a gateway service. In this gateway service, you can see there are different endpoints: login, upload, and download. So first the user is going to log in. If he is the correct user, he is going to then upload the video. Once the video is uploaded, the converter service is going to convert the video into audio, and then notification service will send us a message on the mail. This is already discussed in the architecture diagram, but I'm just trying to explain you the code here. So if you have any issues, feel free to let me know in the comment section. But this is the code. We also have Docker file for each service. So we are going to create Docker image and push them on Docker Hub. So I'll show you that as well. Along with this, you can see there are Helm charts. So Helm charts have 3 different charts for MongoDB, for Postgres, for RabbitMQ. And we are deploying this on our cluster using Helm charts. You can see templates here. These are templates for persistent volumes, persistent volume claims, secret, service, stateful set. So using this chart, we can deploy all of these Kubernetes objects, and you can find the values here. And we are going to change this when we deploy it. Similarly for Postgres, and similarly for RabbitMQ. So once the cluster is ready, we are going to create node groups and then start deploying these one by one in our cluster. And then we will have our app ready. So this is going to be a very fun project. If you are excited, please like this video right now and comment microservices in the comment section. Let's go and check if our cluster is ready. So it's still in creating state, and I have to wait for it to come back in active state. So let's pause the video and come back when this is active. Alright, now the cluster is in active state. Let's go to compute and start. Let's go to compute section and create a node group for our cluster. So I'm going to click on add node group button. For name, I'm going to say node group. IAM role is going to be my Amazon EKS node role. Again, if you don't know what policies are there, this is the policies attached to this particular role. Next, we are going to select compute and scaling configuration. For AMI, I'm choosing Amazon Linux, on-demand, T3 medium. But for scaling configuration, I'm just choosing one node here. So one node is enough for your application. So let's choose one and then click on next. For subnets, I'm choosing all the subnets here. Click on next. review everything, and then click on create. This will start creating our node group, and we will soon have one node running. So now it is the node is going to be created. Let's go ahead and connect our cluster with our CLI. So I'm going to open my terminal here and run the command AWS EKS update -cube config -- name, and the name is going to be microservices. So whatever name you have for a cluster is what you put here. So microservices -- region, and we are using a region which is North Virginia, also known as US East 1. So I'll be putting US East 1 as a region. So region is going to be US-East -1. Okay. Once I do this, it should give me a message saying updated, added new context, which means now our cluster is connected with our CLI. So if I do kubectl get pods, you'll see there are no pods because this is a fresh new cluster. So we don't have any pods right now. Also, if I show you namespaces, we only get the default namespaces that we have. Okay, all right. Let's go and try to deploy our application now. And once the node is ready, we will also be able to see that. So right now the node is not ready. So I'm going to go to my folder which has the code in it. So it's microservices Python app. If you can do it from here or either from your VS Code too. It will work the same. So right now we are first going to deploy. So first we will start with deploying the Helm charts. First we'll go ahead and deploy the MongoDB. In MongoDB, as you can see, these are the values which we are using in this templates. So I'm using the username as Nasi, the password as Nasi1234, which you can choose to change if you want to, because we are going to be connecting to our MongoDB database using that username and password. So if I show you Mongosh, so this is the string, and we are going to be using our username and password here. So you can choose to use the same if you want to, or you can choose to put your own username and password and then try to connect to your MongoDB database later on. But if you see here in this README, I have all the steps and things noted down. So you need to run this command to connect your cluster with the CLI. Once you do that, we will start with deploying our Helm chart. So we are going to start with MongoDB, and you need to go into the folder which has the charts in it. So I'm going to go inside my folder, which is CD Helm charts. So let's go here, CD Helm charts. In this, I have 3 Helm charts: MongoDB, Postgres, and RabbitMQ. If I want to install MongoDB through Helm, I'm going to go inside this. And if I do ls, you should be in the correct directory which has chart and all these things. So I'll be running Helm install name of the chart, Mongo, and then dot. Make sure you can run this command only when you have Helm installed. So once I do this, it will give me an output saying deployed, and then we should have a pod running for Mongo, or not just pod, but everything that we have here in the template. So pod, PV, PVC, secret, service, stateful set, everything created. So let's wait for this to show us the deployed state, and then we can check if the pods are ready for Mongo or not. You might also need to wait for the nodes to be ready. So if I run kubectl get pods, let's see if our MongoDB pod is ready or not. So it's in container creating state. And if I do -w to go in watch mode, we should be able to see it running now. Okay. So MongoDB is running along with the pod. Let's see what other things do we have. So I'll say kubectl get all, and then we should be seeing everything that is defined in the Helm chart template. This is how easy it is to deploy things through Helm chart. And Helm chart is a package manager for Kubernetes. Very, very important to learn. So you can see Helm chart has created pod. It also created service and a stateful set. Along with this, we also have PV or persistent volume. So I'll say PV, and you can see a PV has been created for MongoDB. Awesome. Let's deploy RabbitMQ and Postgres similar to this. So in MongoDB, we don't have to make any change apart from the secrets or the values here. So you can change this because this is what we use here in our username, password stuff. So if you want to change it, you can change it, or else you can use the same to avoid any issues. And later on, when you practice it again, you might then try changing it. So let's go and deploy a Postgres similar way. So I'm going to go inside the Postgres chart now. So I'll say cd Postgres. In this, you'll see chart, init SQL, templates, and values. So let's see here in the VS Code. So values hold everything. Again, we have a username for the database, also the password, and what database do I want to use. So you can change the username and password if you want to, but let the database be same because we are using that in the code. Along with this, you have init.sql, which has some query in it, and I'm using my email ID and my password. So if you want the email to be received on your own email ID, put your own email ID here. And also we are using that in the notification service. So if I show you, we are using, this is the email address that I'm using, and I'm going to get the mail on here. So I already have it in my local machine. You can see there is a Batman account, and I'm going to get the email here in this particular Gmail. If you don't know how to get this password, you have to check the previous Netflix video where I shown you. Along with this values.yaml, we also have init.sql, which has some queries to create a table and to add this particular data inside this table. So I'm putting my credential, which are the email ID and the password. If you want to use your own, you can use your own, put your own email ID here. And we are also using this email ID for notification service. So if I show you, this is a notification service. It has a secret.yaml, and in this I'm passing my Gmail address and password. So if you don't know how to get this password, you need to check the previous video where I've shown you how to create app passwords after doing this 2FA or two-factor authentication. So I explained you that in the previous Netflix DevSecOps video. So you can get to know how to put this. You need this because we are going to get notification on our email ID. But for now, let's go ahead with deploying our Postgres without making things complex. So in the templates, we have two things, deployment and service. And then once it is created, we are going to connect and also run the queries inside the database. So let's go here. I'll say ls. You can see the charts in it, templates and values. So I'll say helm install, name of the chart, I'll say Postgres, and then dot means I want to install the chart that is present in this particular folder. So we have a folder here and it has all these things. So I'm pressing dot. If you are not in the correct folder, you need to put the exact value instead of the dot. So I'll press enter now, and this will go ahead and start creating the things in the templates of this particular chart. So you can see it says deployed, and if I do cube ctl get all, you will be able to see Postgres along with MongoDB things that were created earlier. So let's see. So you can see Postgres is also running. It has a service created. It also has a deployment created and an replica set. So now that this is created, let's go ahead and connect to it. And then we are going to run the queries in the init.sql. So how do you connect to it? We are going to connect with a string. We are going to be connecting to this to a string, and you can find the string here in the README section. So this is a string to connect to MongoDB, and then we have a string to connect to our PostgresDB2. So if you want to connect to MongoDB or PostgresDB, you need to have Mongo and Postgres installed in your machine. So let's first go ahead and connect to our Mongo, and then we will go and try to connect to our Postgres as well. So I'm going to copy this and paste it here. If you see here in this, you need to change few things. First is to put our username, and I'm going to have the username in the values.yaml. So I'll go here in the MongoDB values.yaml. My username is Nasi, so I'll say Nasi, and the password is Nasi1234, so I'll say Nasi1234. For node IP, I need to get the IP address of my node. So how can I get this? I can go here in the node group. In the node group, I'm going to refresh, and you can see the status is active. I also have a node created, so I'm going to click on this and then click on the instance ID. Here in the instance EC2 dashboard, I'm going to get the IP address of my node, which is what I will be using because this is a node port service type. If you can see, this is a node port service type. Along with this, it's also running on some particular node. So this Postgres has been mapped on port 30,003, whereas MongoDB is mapped on port 30,005, which is why we're using 30,005 here. So I'll put my IP address, and for us to connect to this, we also need to have 30,005 open in our security group. So if I go here on the dashboard, you can see security group does not have 30,005. So I'm going to open that. And there are a list of different security group rules that you need to add. Let me show you. So I have a screenshot created. Yeah, this is the screenshot, which is to show you what particular ports you will require. So we require 30,002, 3, 4, and 5. This is for gateway, this is for Postgres, this is for RabbitMQ, and this is for MongoDB. So let's go ahead and add all of them right now. So I'll go here, click on enter inbound rules, and I'll click on add rule, custom TCP 30,002. It's anywhere IPv4, and 30,002 is for gateway. So I'll put this gateway. We are using gateway service later on to validate our application, so I'm adding it right now. 30,003 for RabbitMQ or Postgres. 30,003 for Postgres. Again, this will be from anywhere IPv4. Allow rule 30,004 anywhere IPv4, and this is for RabbitMQ. We are going to create queues after we deploy RabbitMQ through Helm chart, so we also need to have this open. If any point of time you face timeout issue, this is because you don't have ports open in your security group. Then lastly we have 30,005, which is MongoDB. If I show you right now, if I try to run this, I'm going to get an error. It is going to try to connect, and after some time it will show me an error, and it will not be able to connect because we don't have 30,005 opened yet. So let's go and add that, and I'll show you it will connect in a second after we apply or we add the security group rule. So I'll go here, add 30,005. So 30,005 anywhere IPv4 Mongo. And if once I save this rule, you can see, let's try to connect again. And you can see I'm inside the MP3 database. So we are able to connect to our MongoDB database, which means we have our database properly configured and these credentials are also working. So let's go and exit from here and try to connect to our Postgres database, because we are going to running the queries. Because we are going to run the queries inside the database. For now, this MongoDB database has nothing. It will be storing our MP3 and videos after we convert it. So for now, we are going to just store our credentials, which are the username and password, inside Postgres database. And to connect to your Postgres database, we need to use a string, which is PSQL string. So let's go back to our README section. And in here, if I search for PSQL, you can see this is the string we are using, which has Postgres, username, password, node IP running on port 3003, and then connecting to OddDB. So I'm going to copy this and paste in my terminal. Let's clear the screen, paste it here. I'm going to put my node IP first. So node IP I can get from the node, which is here. I'm going to the node, clicking on instance ID, and I get this here on the EC2 instance dashboard. So let's copy this, paste it here. In this, I'm going to pass my password and username. So the username and password is already stored in this values.yaml, and you can change it if you want to. So the username is, password is CND2023. It has CND2023 because I did this project in the Cloud Native Day recently. The username is Nasi, so I'll pass that here. Okay, once I do this, I should be able to connect to my Postgres database if it is properly set up, if the port is opened in the security group. So if I press enter, it should bring me inside OddDB, which is where we are right now. So if I show you right now, it's completely empty. There are no relations, there are nothing. So if I copy the things from here, so I'm do Control A, copy everything, and then paste it here. So once I paste this, it will go ahead and create a table and also insert the data in it. So now if I do /d, let's do it small. So if I do /d, you can see a table has been created. And if I show you what is inside this table, I'll say select star from auth user, and you will be able to see that this particular thing has been inserted because we used the insert query here. So once I do this, you can see an insert has been made and we have the data inside this auth user. So this is what you need to do in the Postgres side. So let's go and exit from here. So and say exit or /q. Okay, let's clear the screen now. MongoDB is created. We also have Postgres created. Let's go and deploy our RabbitMQ. RabbitMQ is a queue service which lets you process things. So in our project, we are using RabbitMQ to hold the video which is going to be converted from the converter service and then put it in MongoDB. So right now we have Mongo created, Postgres created. Let's go and deploy our RabbitMQ as well. So RabbitMQ we are also going to deploy through Helm charts. So if I show you, this is the folder which has RabbitMQ charts in it. So I'll say RabbitMQ here. In this you can see charts, templates, values. For templates, we are going to be creating config map, PV, PVCs and all this stuff. So you don't need to change anything here. We are going to deploy this and also create the queues on the UI dashboard of RabbitMQ, which we are going to see very soon. So let's say Helm install Rabbit and then dot. Once I do this, it will start creating all the Kubernetes objects, and we should be able to see a pod, config map and other things that are present in this templates. So you can see it says deployed, and if I run kubectl get all command again, I should be seeing more things apart from what we have here. So you can see RabbitMQ pod has been created, a service on node port 30,004 has been created. So let's go and try to access our RabbitMQ on port 30,004. So I'll go here in the UI, on the browser, copy my node IP address and open it on 30,004. This is where our RabbitMQ is running. Once, if it is running properly, we should be able to see this login page, and we should be go inside this to create our queues. So I'm here in the login page. By default, the username and password is guest. So I'll say guest, and I also passed guest here. So guest and login. Once you are logged in, you should be able to see a screen something like this. And now in this screen, we are going to be creating queues. Right now, we don't have any queues. So I'll click on queues here and create two queues, one for MP3, one for video. So I'll click on add a new queue option. Once I click on this, I'm going to create a queue. So the virtual host is / for default. I'm going to click, for type, I'm going to click classic. Name is going to be the name of the queue. So the first queue is MP3. And this is all you need. I'm going to click on add queue option. Similarly, I'm going to create another queue, which is going to be of video. So let's click on add queue here. And a queue has been created. I'll do the same and pass the name as video now. So MP3 and video, and click on add queue. The second queue has also been created. So this is all you need for RabbitMQ side right now. So we have our RabbitMQ, our Postgres, our MongoDB created through Helm chart. So I hope now you have an idea of how to install Helm charts and what are Helm charts actually. So let's go and deploy our microservices individually to create our application and also to validate if we are able to convert a video into audio or not. So let's go and go inside in this source directory. So I'll go. So this is the source directory or source folder. Let's go inside this folder, and you can see 4 different microservices: the auth, converter, gateway, and notification. Let's go first in the auth service. And I already explained you the code, but if I show you right now here in the auth service, we have manifest, which are the Kubernetes manifest file responsible for creating config map, deployment, secret, and service. Then we have Docker file, which will let you create a Docker file out of the server.py and push it on Docker Hub. So we are also going to do that. I already have the images created. You can see I'm using my own image, which you can also find here on Docker Hub. So you can choose to create your own, or you can also choose to use my images if you want to. But I'll show you how to create an image and also push it on Docker Hub, so it should not be a problem. So if I show you my profile here, this is my profile, and I also I have all the images that you want. So it's the gateway is here, auth is here. We also have converter and also a notification image. So now I'm going to show you how you can create an image and also push it on Docker Hub and then use it in your microservices application, deploy our application, and then validate it. So let's go back to VS Code, and in this we have this code which is going to log in, and if the user is correct, which is stored in the Postgres database, we are going to get a JWT token. This JWT token or JSON Web Token is going to be used to upload the video and also download the video. So make sure you are passing it correctly. You are using the same user which is present in the Postgres database that is holding our credential. So I'm going to now go ahead and create a Docker image and then push it on Docker Hub for auth service, and then we'll do the same for other services as well. Alright, let's start with creating our Docker image. As you can see, Dockerfile is here. And if I show you the contents inside the Dockerfile, this is the Dockerfile, which is using a Python 3 image. They're using the commands to update all the packages, to install these stuff, using the work directory as app, copying the requirement.txt, installing it, and exposing the application on port 5000. So this is the image for now. I'm going to run the command docker build -t auth and then dot to start creating an image from the Docker file present in this particular folder. Once it is created, we should be able to see in our local machine, and then we will be pushing it on our Docker Hub as well. So I already have it pushed, but once I push it again, it will show me updated 1 second ago or 2 seconds ago. So let me show you that. So I already have it uploaded. You can see it's been uploaded 20 days ago, 21 days ago. Once I upload it again, it will show me updated a minute ago, seconds ago. So let's go back to our terminal, and you can see it's still in creating state. It has 6 layers, so it will take some time. Okay, so it's almost done, and now we should be able to see this image being created in our local machine after we run the docker images command. So it's right now it's installing all the requirements required for this particular project. You can see the requirements here in the requirement.txt. So we're using Asteroid, Click, cryptography, all these things for this particular project. So now the image has been ready. If I run docker images, I should be able to see an auth image created 9 seconds ago. Let's push this, and to push it we first need to tag it with this name and then do it. I'll say docker login first to see if I am logged in or not. So okay, it says login succeeded, I'm inside. I'll now say docker tag, and you can also see the commands on how you can push this here on the Docker Hub. So in the Docker Hub, you need to click on create repository and give the name. So let's say you're creating an auth. So you'll say auth here, and I already have it created. Once you create it, you will get a command here that you need to push. So I'll say docker tag, name of the image that is locally, and then the name that you want to put here. So I'll say docker tag, the image name locally is auth. So I'll say auth here, and then I will have to use the new name that I want to put here in my repo. So I'll be using docker tag auth latest. So I'll say latest and the new name that you want to be using, and we have to use the name as username / the name that you want to push. So I'm going to copy and push this. So docker tag local name tag new repo, the repo name which is auth here, and then the tag name. So the repo name is nasi101 / auth. So I'll press enter and it will tag me, and then if I do docker images, you'll see a new image has been created. So you can see a new image here, which is 2 minutes ago. Let's push this. I'll say docker push and then the name. So it's going to be nasi101 auth. Once I do this, it will go ahead and push it in my repo, and you'll see very soon that the repo for auth has been updated. So this is auth right now. Once it is pushed, we should be able to see that it has been updated, and we will be doing the same for every other service. I already have it created, so you can follow the steps to do it, and I'm not going to repeat that just to save time. So you need to first click on create repository, copy the commands to tag it, and if you face issues, make sure you are logged in, and then after you create an image, you are going to run docker push for all the images that you have. Now these images are used in the manifest file. So if you see auth service has manifest, which is deployment, and we're using it here. Similarly, it also has secret, which is the JWT. This is the Postgres password and JWT secret. You can choose to keep it as it is if you want to, or else if you want to change, you can change it. Next, you have service. We have a cluster IP service, which is running on port 5000. So yeah, that's what it is. Let's refresh the page once it is pushed. So it's still pushing right now. Okay, it's pushed. And if I refresh the page, I'll be able to see that the auth service has been updated right now. So updated a few seconds ago. So you do the same for every other service, for auth, for gateway, for converter, for notification. If you want to use your own image, or else you can use the same image that I have here just to avoid facing any issues. You can see converter also has a manifest file and it's using my own image in the C101 converter. Similarly for gateway, I have manifest files and it is using my own gateway image. So you can use my own image if you want to, or you can create your own. So on the auth, these are all the manifests. So let's go and apply all these manifests to have config map, deployment, secret, and service. So I'll go here on my terminal, clear the screen. If I do ls, you can see a manifest folder here. Let's go inside this manifest and run the command kubectl apply -f and dot. So apply everything present in this manifest file, which are config map, deployment, secrets, and service. Once I do this, I should be able to have all these things created. So you can see config map created, deployment created, secret created, service created as well. So I'll say kubectl get all, and I should be able to have pods running. So if I show you, deployment has replicas of 2, so we should have 2 pods running. So you can see 2 pods are in creating state, and if I do the watch mode, I will be able to see. So get pods, and you can see auth has been created and also running, which is what we actually want. Okay. Next, we are going to deploy the gateway service. So I'll go back and go inside the gateway service. So cd gateway. Similarly, I'll have to go inside the manifest file for gateway, which is here. Sorry, gateway is here. Inside this, we have config map, gateway, secret, service. So you don't need to change anything. Let's go into manifest folder. If I do ls, you can see all these things here. So run the same command kubectl apply -f dot. Once you do this, it will create config map, deployment, secret, and service. So if I do kubectl get all command, we should be able to see new things created for gateway. So yeah, you can see here a service for gateway of nodeport is created. Deployment has been created. Similarly, there are 2 pods which are still in creating state. If I do it again, it should be now in running state. So microservices, the benefit of microservices, you can individually scale a particular service or descale it. So if you're using auth very much, you can make it 3 or 4 rather than just 2. Similarly, if you're not using gateway much, you can make it 1 to save resources on your nodes. So this is what the benefit of microservices. You can individually scale up, scale down, and if there's any problem, you just need to configure that particular thing rather than configuring the exact application. This is why companies are shifting from monolith to microservices. Okay, let's go and deploy our next service, which is the converter here. So I'll go and go inside converter. In this, I'll have to go to manifest. In the manifest, we have config map, converter, and secret. So let's go and apply it. So I'll say kubectl apply -f and dot. This will start creating config map and everything that is there inside this particular path. So let's go and check again if we have everything created for converter or not. So we should have config map, we should have deployment, we should have secret. So you have a deployment for converter, which is running 3 pods. You can see, 4 pods, and very soon it will create all those. We'll have all those pods running. Again, if you don't require these many pods for converter, you can always scale up or scale down. So you can either change the replicas here in the converter section. So if I go to converter service, which is here, rather than having 4 replicas, I can make it 2, or I can make it 1, or I can also run the command kubectl scale deployment. Name of the deployment is converter. So I can make it converter -- replicas and make it 2 rather than 4. So once I do this, it will give me a command saying deployment scaled. Now if I run kubectl get all, instead of 4, I will have just 2 because I've scaled it. And this is how you can do it in microservices using the command. So right now we only have 2 pods which are running and the other 2 are terminated. Similarly, let's deploy the last service before we go ahead and test out our application. The last one is notification service. In this notification service, as I said, you need to put your own email ID and your password. The password is how you can create it from the app password. So this is my email and this is my password. Once I do this, I should be able to get an email here in my email ID. So let's go here. Let me show you. I don't have any email As of now, these are all the previous ones. So I'm going to delete them right now. If you can see other as well, these are the ones from the previous project, which is Netflix one. So I'm going to select everything and delete it just to have a fresh Gmail. And after we convert it, we should be able to see an email here. So let's go back and try to deploy everything in the notification part. Make sure you are putting your own email and your own password to get the emails in your own email ID. So I'm going to deploy this, which is going to create config map, notification deployment, and secret as well. Sorry, I'm inside the converter again, so I'll need to go back and run it in the notification. So I'll go in manifest and run the same command. Now once I do this, it will be created. So I'll say kubectl get all, and you will see pods for notification as well. Okay, yeah. So we have notification ready along with all the ports. So let's go ahead and test out our application if it is actually going to convert a video into audio or not. So if you remember, we have the audio, we have the video present in this particular assets. So I'm going to go in that folder. So let's go back. Ls, this is the asset. So I'll go inside the assets folder. And if I show you, this is the video.mp4 that we have. So I'm going to convert this video into audio, and we should be able to see that as well. So when you are here at this point, you need to go to the GitHub repo. In this GitHub repo, you can find the validation APIs here below. So once you deploy everything, we have the API definition, and I also have the steps on how you can create the app password. If you don't know how to create this, you can follow the steps, or you can also check it out in the Netflix video where I've shown you how to do it. So once we apply everything and we have everything being created, we are then going to go ahead with this API definition. First, we need to log in. So we are going to log in using our email and password that is stored in the Postgres database. So I'm going to copy this. So let's copy, and we are going to paste it here. In this curl, we are going to pass our username and password. For Postgres, it's here. So I'm going to copy my email and my password. The password is 123456. So I'll say 123456. And this is my email. So my email is this. Let's copy. You need to put your own email because these are the things that are stored inside the Postgres. If you remember, when we created the auth user, we had inserted something. So we require to put the same thing here, the email and the password. Once you do that, you need to copy the node IP. So I'll also do that from here. This is my node IP. So I'll copy this. You can get it from the dashboard, from the UI management console if you don't know. So let's go here and paste our node IP. Once I do this, if my username and password is correct, we should get a JWT token, which is a long string. As you can see here in the auth section, we are going to get a JWT token created if everything is correct according to the database stored, according to the credentials stored in our Postgres database. So let's press enter. If it is correct, I should get a string like this, which is what a JWT is. So if I copy this and I show you what it holds, let's go to base 64 decode and go to this website. In this website, I'm going to paste my string, and if I click on decode option, you can see the data inside it. So it's an algorithm using HS256. The type is JWT. Username is I am Batman, and this is expiry date and all the other things. So if you have the correct one, you can get this kind of JWT token, which is what we're going to be using to upload and download after the video is converted. So let's copy this and let's go to the next endpoint, which is the upload endpoint. So I'm now going to upload my video, which is going to be converted using the converter service. So let's copy this and paste it here. In this, we need to change few things again. So let's clear this first to avoid unnecessary things. So I copy and paste it. I need to paste my node IP, so I can get the node IP here in this part, in this sensitive details part. So let's copy this, paste it here. Along with this, I also need to put my JWT token that I got right now. So I'll copy the JWT token from here, copy, and paste. Once I do this, if everything is okay, it should give me a success message. As you can see here, if the upload has been done, we should get a success message, and then the converter should also convert it, and we should also get an email on our mail. So once I do this, we should get a success message if everything is okay. You need to make sure you're in the same path where you have video.mp4 as well. So let's wait for see what output do we get, and make sure these are all ports are also open. So we get a success message, and let's go here in our email, and you can see an email has been, we have got an email right now. It's 12:13, it's 12:14, and in this email we have an ID, which is what we are going to use to get the MP3 that is stored in our MongoDB database. So I'm going to go here and copy the endpoint for download, which is here. So download endpoint, I'm going to copy it and paste it here. In this download endpoint, we need to pass the FID. So this is the FID, and I'm going to get the FID from the email, which is here. Let's copy it, paste. Along with this, I also need to put the node IP, which is here. So let's copy the node IP, paste it here. Along with node IP, I also need the JWT token. So let's put the JWT token here. And this is all you need to download. Once it is downloaded, we should be able to see an MP3 file being created in our assets folder, because this is where we are running it. So if I press enter, you can see a download has been started and it's been downloaded. If I do ls, you can see a video.mp3 has been created, and let's try to test it out. So this is actually here in this microservices Python app. Assets is here. We have video.mp4 and we also have video.mp3. So let me show you the validation. This video is so this was the video, and this is the audio. So this was our project. I hope you have understood how you can create a microservices application to convert video into audio using all these different tools. I hope this was informative. If you have any questions, any doubts throughout this project, let me know in the comment section. I can help you out. Let me know in the comment section, but this is very easy or straightforward application, but a very important one that you can mention in your resume, which will showcase your expertise in different tools. I hope you complete this and you also share it on LinkedIn. For now, let's go ahead and delete all the resources you have. So we just need to go to the AWS account. So I'm here in my AWS account, and I'm going to go to the cluster that's created. First, we are going to delete the node group, and then we are going to delete the cluster. There is nothing else apart from this, because these are all the things we have right now. So I'm going to go to node group, select the node group, click on delete, and node group, the name of the node group that I have added. So I'm going to delete it. Once this is deleted, we have to wait for some time till this is deleted completely before we delete the cluster, because if I do it now, it will tell me that there are nodes in node group, and first you need to delete that, and then you can delete your cluster. So this is the end of our Python microservices application. I hope this video was informative and you have completed the project successfully. If you did, make sure you share it on your LinkedIn or on your resume. Thank you and have a good day.